drop one. Probably you can just read it. Yeah. So I'm probably gonna drop that. We could just do it in your last semester. Yeah, let's take it together then.
Back door works if you're a little late. Street entrance. So let's see that. Right, that was this is my intro. The subselects are the most common word to describe what we talked about a little bit last time, which is a select that's inside another select. And yeah, you know, one of those horrible top 5 examples had lots of subselects. Screen down. Let's see if this works. Front lights off. So I made up some files that will, help us to do this. I can start typing as soon as you can see what I'm typing. Hey, we got a light. So the idea of a single row subselect is simple. So we can do an example that would work for our table. Something like select dname Sal is not an example of something we need a subselect for from Aunt Bubba. Yay, where, and you can use a subselect after a where clause in the following manner, where Sal is, I don't know, bigger than Didi. Let me go to a new line to start the subselect. We'll pretend that this is a continuation line. Subselects go in parents. So then we would say select, just to show the syntax, Sal from imp of a 0 to where imp no equals 735, which would be Lasorda salary. Everybody making more than Lasorda, which is pretty much the whole world. All right, and then a semicolon. So this is a single row subselect in the sense that what we are selecting here is, it's a scalar. Okay, so in a more realistic example, what we might be picking up this number from some other table or something, and then this would be an easy way to get that number for comparison purposes instead of doing a join or something which is time consuming. So there are plausible reasons to do a single row subselect, and this is the syntax, and it's very easy. All right. The thing about the single row subselect is that what characterizes it is that usually you do the subselect after a big 6 relational operator comparison. So you can recognize these things by that. And then for a multi-row subselect, we change the set of operators to include some that you haven't seen before. All right. So now we'll go looking for some of my prepared stuff. Print working directory. Yeah, we're in the right directory. Let me take a guess. I tried to do these as subselect something. Let's try subselect select1.sql. All right, that worked. Okay, so this is a multi-row one, and the idea here is that I'm selecting more than just a scalar. All right? So what I'm doing here is selecting the set of salaries, as it were, for department number 10. And then what we have here is a more complicated operator than the usual big six. And there are two flavors of this, bigger than all and bigger than any. All right, and those are used for a subselect where I am selecting more than a single scalar. So at this point, I'm going to show you how this ran, and I think we have a file called select1.dat. We're going to try that if we can spell it. Then again, maybe not. We'll go look at
Someone told me
if
that's
it'll let me.
awesome.
All right, subselect. Oh, it's called subselect one was called subselect one.script. Well, crap. Okay. So that's what I did wrong. Wrong extension. Hopefully this will work. All right.
Professor,
Yes.
can you replace all with star asterisk?
Did I replace what?
The word all, where it says where cell is more than all.
We're talking about here.
Yeah,
Can I replace?
it with a star like asterisk. Because I remember you said that asterisk means all, so instead of using all, can you use a star instead?
Oh. Right. Asterisk as in, oh, this is a different idea than star, meaning, all columns.
Okay.
A completely different use of the word all. Okay. So here we are, and so this is the one that we're running, and this is the output. Okay. Fine. So what we ended up getting here, in other words, when there's a question about what does all mean. And as you can see, we're only getting a couple of outfielders here, and they're very highly paid outfielders. So what this turns out to mean is I want the players who are making more than the highest paid player in the infield department, which might be Minoso at 85,000. Right. I know he's an infielder. I know he makes 85,000. So this is the set of employees who make more than the highest paid. So that's the sense in which all is used. That's the semantics of all. This turns out to mean bigger than the max. Okay? Now, probably, now you can certainly say less than all. You should be able to say greater than or equal to all. All right? So you should be able to use the big equal all. It doesn't make sense. Not equal to all. So, you know, 4 of the big 6 makes sense here, followed by the word all, and evidently the semantics is max. Okay, well that was fun. Now we're going to try subselect 2. Okay, so this is the other modifier to the, I think syntactically you could use any of the big 6 relational operators here. But this one is bigger than any. And I get easily confused on this stuff because to me, any and all often mean the same. I say for all or for any or for each. Okay, so in math contexts, I have trouble distinguishing between the words, but in this context, we'll see what happens when we look at the DAT file. So exactly the same code as before, but this time we're saying greater than any. And this will turn out to basically mean min. I want people who are making more than at least one person in the infield department. So that would be the lowest paid infielder. And all right, so now we'll see what happened when I ran this on my machine at home. So this time it is called DAT. I took a look and it was called DAT. Select 2.dat. And this time we got 10 people, starting with Mays at 240,000. Okay. And you know, so we got our 285,000 infielders because they make more than the lowest paid infielder. Let's see who else we've got here. We've got Sandberg, the second baseman, at 25,000. That means, if you know your baseball team by now, we are missing Ron the Penguin Say, the low-paid third baseman. Okay? So, had I said greater equal any, I should have picked up Say as well. All right. So, for multi-row, the operators are big 6 followed by any or all, and the semantics that we're given is in effect amounts to in case of greater than the max or greater than the min, and ditto with the other operators as well. Okay. All right. So probably there are 12 of these operators syntactically. But like I said, I can't imagine using equal all. It just doesn't make a lot of sense. Okay. That leaves us with the third thing behind here, which is multi-column. Multi-column, the syntax gets somewhat meaner. And I made one of these too. So let's take a look again. There is a subselect 3.dat. Why didn't I say subselect 3.sql? I think I did on my home computer. I just never pushed it down to Rohan. So we're going to hope that select 3.dat is adequate. It should be. Move this over so we can see it all. All right, vi sub select 3.dat. Happy day. Okay, so here's the syntax. My little comma-separated list, and then here's my where clause. In order to do 2 columns, pause and sale, I make a parenthesized list of the 2 columns. I could do 3 if I were gung-ho. Okay? And then we use in, which we've seen before. There's in and not in. I could use not in. And then what I have in order to do multi-column is a list of pairs where each pair consists of a position and a salary. So my set, which is not contained in set braces, but another comma, I want, this is the set consisting of coach and 2,000, if we can see it all, and catcher and 100,000, because our catcher happens to make 100,000. Okay? So coach 2,000 would include all 3 coaches, Bochy, Berra, and Lasorda. Catcher 100,000 is Ivan Pudge Rodriguez. And I want the names, positions, and salaries for those or employees. And that's exactly what it produced. Okay? So for multi-column, the operators that come into play are in and not in. And the syntax for specifying the sub-select is right. Would look like that. Okay. Now I actually didn't say sub-select, but that's okay. Okay. So I wanted to show you what this looks like. That if we used it with a sub-select, it would look like this. We'll just do the from. Where, and then it would look like this if we did pause and sell. And then in, and then the usual parents, and then you would say select, and then this could be more complicated. All right, and what we would be selecting is pause and sell, et cetera, et cetera, et cetera. Okay. So I wanted to show you the concrete syntax first. When we do this in a sub-select, then we can take advantage of the sub-select so that we don't have to type out these, this list of ordered pairs. Okay. So this is an indication of why sub-selects can be good, because the alternative to using a sub-select here would be to do this, and the sub-select looks a lot better, doesn't it? So okay. So when I get home, I'll try to ship you the other piece of syntax in which we do it the other way. All right. So in some sense, this was how to avoid a sub-select and why to use one. Okay. Well, so I sent you an email about the fact that there is this SQL interpreter online. We'll see if we can get that going tonight. Take a look at that together. And with that online interpreter, yeah, if I never get Rohan to talk to Oracle for the next 2 weeks, we don't have to care too much, because it will give you a way to do it, to do the assignment without even, yeah, there's a certain matter of trust involved on our part, but without necessarily installing Oracle on a laptop. Okay, so, all right, we'll let it get mad at us. Let me look around before I do that, because I did a couple of others. That were constraints, and I have to see what the constraint files are called. So I have constraint 1, 2, and 3 .dat. We'll take a look at those, maybe even type some more. You know, the reason I like to type live is that I have more confidence that you're keeping up with me. I can flash these by you awfully fast. Constraint 1.dat. Now this is one that we did last time in terms of the syntax. Okay. So what I did when I made these files is I created an account which didn't even have these tables in it, and then I popped them in. So I did a describe of emp bubba 02, and this is supposed to look the way it did in your first assignment. The only guy who was not null is ename. All right, and that's sort of an object lesson. So I don't expect, it's not important that you write this down. You can make a note, Initially, after HW1, the only non-null was ename. All right. Now, here's the syntax that I'm pretty sure we did last Thursday in some parallel universe. It seems like a long time ago. So, alter table, emp, add constraint, the magic words, and then this is something that I expect you to know for exams, my constraint naming convention. So the table we're putting a constraint on is emp bubba 02. The column we're putting a constraint on is emp no, and the kind of constraint is primary key. All right. Now, if there were multiple columns in the primary key, then we would simply have another underscore here and the next column, and then until we were done with all the columns that were involved in the primary key. Okay, so that's the convention. And if there's only one column, then it's a unique constraint name. Yay! All right, the rest of the syntax is pretty simple. Primary key, and then the column that's going to be the primary key. And again, if it was multiple columns, this would be a comma-separated list inside the parents. Right, something like grade, comma, roll, or roll, comma, grade. All right, so for the sales table. Now, for completeness, when you're typing up the create table, sometimes you already know, in fact very often you already know what the primary key is going to be. And if you remember, when we were typing up the create table for ename, we said ename varchar 210 not null. Right? You can do the same thing. You can say emp no varchar 25 primary key, comma, and then go on to the next field in the create table. So you can specify the primary key at table creation time, just like you can specify not null at table creation time. So one exam question might be, in how many ways can I set the primary key? Yes?
When you're setting the primary key at the table creation, is that one word or two words? Primary key?
Two.
Two? Okay.
Yep. Now, what I haven't tried to do is to do this with sales. If there are two columns involved in the primary key, can you say primary key twice? It sounds a little bizarre. I've never tried. You can take that as an experiment. Yes?
Well, like in MySQL, you don't put it on, I don't know if you can put it on column, but you put it after the column.
There's a third
primary
way.
key.
Yeah, there's a third way, and it works in MySQL and Oracle and lots of other places. All right, so let me show you the third way. But after I get through showing you this example, and then we'll talk about the other ways some more. So what I did to show you something else is I did the describe again. And when you do the describe again, you're going to find two not nulls. Because primary key implies not null, and Oracle in its wisdom decides to show you that not null after you create the primary key. Okay. So primary key, like I said last time, implies two properties. One is not null and the other is unique. Technically, you can be unique and have 5 rows that have the value null. Okay, nulls are not considered necessarily to violate the word unique. All right, anyway. So I wanted you to see that creating a primary key makes those columns not null. All right. Now, here's the next thing that I did. I tried to hire Balasubramanian. And of course, I had to abbreviate his name a little, the way we used to do in Ellis Island for immigrants. You know, those Polish people ended up with truncated names and fewer consonants on the whim of whoever was doing the paperwork, right? So we cut his name down to Balasub, and I screwed up and I gave him the same employee number as Lasorda. Okay. And this is what it says. Error at line 1, and then it's trying to show me down here that the error was on this line. All right, so don't pay too much attention. It's not double printing. It was trying to show me where the error was. And the error is Oracle number. Wow, it's the first error. Isn't that special? But so is being the 37th error. Only the 37th error is error 37. What you're going to discover when you see these Oracle error numbers is you're going to see a lot of minuses, but occasionally you'll see a plus and occasionally a nothing. And so most of the error numbers in Oracle, according to my informal survey, are negative. But they're not all negative. It's very strange, how they determine the error numbers. We'll have more to say about that later. But okay. Anyway, think of this as -1 as opposed to a dash, and you'll be right. Unique constraint, and see, it's giving me my username. I was doing this as Scott Tiger at my home, followed by my constraint name, because I obeyed my convention. You watched me do it. and then it says that I violated something. Okay? Okay. That's like the signs you see in the Rocky Mountains once in a while. No trespassing. Trespassers will be violated. They never specify how. Okay. Anyway, so we violate the unique constraint, and you know, it's nice to see what the error messages look like, and it's nice to see that we are protected against certain integrity errors, right? We can't have two employees with the same no. All right, so and that should be the end of it. Now I'm gonna type a little bit. Create, sure. We'll try to get it semi-right. Table, T, and then we have a list, and then we have a comma, then we have, more stuff, and then we have a comma. Just imagine that I'm doing this in Oracle, and then we have another comma. That's not a comma, that's comma. And suppose those are all the parameters that I'm going to, all the fields I'm going to have. After I type all of the field descriptors for the create table, this is option number 3, you can then type constraints such as primary key, and in our case it would be no, and then the close, and then the semicolon. Now it's a semicolon. All right, so if it's a 1-column primary key, you can just say primary key after the column attribute, and it's done. But a lot of people, when they're doing this, if there are a lot of fields, don't like to bury it in the field descriptors, and so instead they'll put it at the end, along with other constraints. So after the last field descriptor, you can do another comma, and then say primary key, red ID, whatever your unique ID is. All right, so there are 3 ways to do this. There are 2 ways to do it at table creation, either as part of the field descriptor or after all the field descriptors. Or if you want to do it after table creation, which is the position you guys are in, then you use alter table add constraint. Now, what's an advantage of alter table add constraint? This is the way I'm going to make the class do it. Why am I making you do this? And the answer is, yeah, it's more natural to put in the constraint name. You can do it, but according to my memory, I can slip a constraint name in there, but since I'm not using the words add constraint, the syntax according to my memory is possible. But generally, when you do it during table creation time, people don't put in a constraint name. They let Oracle do it for them, and they take the horrible random string that Oracle produces as the name of the constraint. Yay. Okay. Well, there's that one. All right, any questions so far? We've done primary key, also known as a specially selected candidate key. Yes?
So for exam purposes, the answer is 3 ways of...
Yeah, but if I were to be, gung-ho on this on the quiz, then I might say name 3 different ways to establish a field called UID as a primary key. And then you would, sort of I'd have to leave you a lot of space, so I probably won't ask you to do it. And then you would discuss those 3 different ways of doing it. 2 of them are at table creation time, and one is after table creation time. Now, of course, if you want to change the primary key from red ID to social security number or something like that, then you say alter table emp Bubba 02 drop constraint, and then the constraint name. So sometimes you decide you don't want a particular constraint anymore. I used to have a constraint that the salary had to be greater than $6.73. But then Brown became governor and he raised the minimum wage to $70.50, and they closed all the McDonald's in the state. Nevertheless, you've got to then do something and maybe change a constraint. That would be a check constraint, saying what the minimum salary had to be. Okay? And I'll give you examples of check constraints later. But so we're trying to deal with primary key constraints now, and I think I'm done. And I'm ready to go on to foreign key constraints, which is a longer story. Okay? So the foreign key constraint is the primary constraint that's used to tie two tables together. And the usual device is that the tables will have a common column name and type. Now, as you'll see when we look at the syntax, the column names could be different, but the type should be the same. All right, so I could call it empno in one table and UID in another, and as long as the types were the same, I could still use it in a foreign key constraint. When you do a foreign key constraint, one table is known as the parent and the other as the child, according to me in most books. Okay? And we'll see how that works. For now, let's discuss the easy, the obvious ones and the ones that I will ask you to do for homework. By the way, like I said, we've kind of solved our homework problem. I'll talk about that too. And I'll email you out an assignment probably tomorrow. And okay. The employee table and the info table share the field empno, as most of you still remember. And that makes empno a good possible column for establishing a foreign key. Now, in this case, since last name is in the employee table, intuitively I'm going to make that table the parent. And info is sort of auxiliary information about the player, so intuitively to me, info is the child table. All right. Now the other natural pair is determined by the common field DEPTNO, D-E-P-T-N-O. That field is present in the employee table and the department table. And now things turn around a little. When we're talking about DEPTNO, the primary table that has information about department, like what is the name of the department, and important stuff like their motto and where they eat, that's in the department table. So this time, when we're using DEPTNO as the foreign key, the employee table will be the child, and the department table will be the parent. Okay? Now we could do it the other way around, but that's the correct instinct. Okay. Fine. Constraint 2. Whoop! Wrong arrow key. So at the top, we have the syntax for a foreign key constraint. Now, not surprisingly, we understand it over through here. So it's alter table info, which is the child table in this case. All right? So the child table is the one that you establish the constraint on. And what we say about the child is you have to have a parent, in effect. And we're going to say who your parent is. All right. The name of the constraint is, we're using the employee number field in the info table, so it looks like this. And then foreign key is empno, which is the empno in the child table, which is the info table. And then we say references emp bubba 02. Yes?
Don't you just specify what column you're referencing?
Don't I just what?
You specify M02 parentheses the column that.
All right. I'm still not getting the question.
Yeah, so references M02.
Yeah.
It would then be like a parenthesis, then the column in M02 that you're referencing. Because you need to link that you column through it.
All right. Are we okay through the words foreign key? Or do you want to do something before we get to that? And then, right, convention says that you then specify the column or columns that are in the foreign key. Technically, a foreign key can be multi-column too, as well. Okay? And so I'm expected to say which column is going to be the foreign key the same way as I say which column is going to be the primary key. Now, you have to specify the parent table because Oracle's not going to guess. So pretty much all of these words I think are kind of required. I don't know of any way to shortcut this. I know a way to long cut it. And the reason for long cutting it is the thing that I talked about before. It could be that although the values are the same, I'm using the name empno in the child table and emp number in the parent table. All right? So suppose I have two different column names for whatever reason in my mind, but it's the same data. All right. Then what you can do is after emp of a 02, you can put parent empno parent. I can't write and display screen at the same time. Okay, so I'm telling you that the long version of this command would say left parent empno right parent semicolon. Now, see, the default is to assume that the column names are identical in the child and the parent. When that isn't true, then you have to mention each of the two column names. So there is a longer form than this. And that's what it consists of. All right, and it makes sense. Okay. We're not done talking about this before we go on and look at the results. When you establish a foreign key from a child to a parent, and most of the time, you know, it will be a shared column and a shared column name. There is a restriction, and Oracle will hold your feet to the fire on this. And the restriction is that the column that you pick in the parent table needs to be a primary key. So this worked because I made empno a primary key in the parent table first. Otherwise, Oracle would tell me, no, you can't do that. Sorry. All right. There are other immediate checks that Oracle does when you try to establish a constraint. One of the things it tries to do is see that the current value of the table is not in violation. So if I have two employees with employee number 735 and I try to say primary key empno, it will tell me, yeah, I can't do that. And the reason is, you know, your table is already in violation. Okay? So how could my table already be in violation with the command at the top of the screen? And the answer is that the idea of one of the ideas of the foreign keys is there should never be orphans. Every child should have a parent. Okay. So if it turned out that I had an empno of 623 in the info table, and there was no empno 623 in the parent table, then I couldn't run that line, because the mere act of creating the foreign key would create an immediate orphan, somebody in the child table who had no parent. Okay? All right. So that's all we're saying, and it should be understood. And so, you know, and that's the right way to think about it in terms of child table, parent table. There shall be no orphans. Okay. Well, so now we can go down past the top line. So my syntax was okay. It said table altered. And then we come to this next thing, and this might be part of your assignment or not, to sort of recheck this, but I checked it for you. I tried to insert into the child table the employee number 666. And I was really thinking more like a nickname here. You call them what you will, Old Scratch. Many words for the devil in our culture. And I tried to put that into the info table. And of course, there is no parent row with the employee number 666. So this is in violation. If I'm allowed to insert this line into the info table, then I'm creating an orphan. Okay, and it won't let me create an orphan. And it didn't. So it said there was an error, and it said, what kind of an error? Did it say foreign key constraint? No, and that's always amused me, because that's what it is. Oracle in its wisdom says, that's an integrity constraint. Oh dear, they caught me lying. Right. And it does mention that it's a foreign key constraint, and see, again, this is the advantage of having a constraint name that makes sense. Now when I see this message, I can say, whereas if I see just a long random string of letters and digits, I can say, all right. And it's quite specific, and verifies what I was saying. Parent key not found. All right, so I tried to make an orphan, and I can't. This is one of two ways that you can get an error once you've established a foreign key. The other way is not as obvious, but it's consistent with my explanation of how the constraint works. Once I've established this, if I say drop table emp Bubba zeros to purge, I'll get this error, or a similar one. Okay? If I say drop table emp Bubba 0 to purge, I will get an error and I won't be allowed to drop the table. Why not? I would be creating orphans. Okay? The only way I wouldn't be creating orphans is if the info table was empty. Okay? So in other words, I would have to drop the info table first before I could drop the employee table, because that's the only way I could avoid creating orphans. So that's another potential examination question. What are two ways to have to achieve a foreign key error, even though it's called integrity constraint error? Right, I could create an orphan on an insert into, or I could create an orphan by deleting a parent. And if I just delete a particular parent, I can't do that either, right? Because then I would create an orphan. So these are things that you can check out, but once you have this foreign key constraint, every row in the child table has to have a corresponding row in the parent table, and that must be maintained throughout the life of the two tables. Okay, so yeah, so that was more complicated than the primary key one. And let's see. I'll type. Let me raise the screen so you can watch what I'm typing. I want to type this. Every once in a while you'll see the word cascade. It shows up when I drop a user as a DBA. So I can say drop user ST17 cascade. And that will not only get rid of the user, but it will get rid of every table and every other object that he ever created. And that's a way to guarantee that I get rid of not only the username, but everything that user ever built. Okay? Where do we use on delete cascade? And the answer is when I'm dropping a table. So if I say drop table mbubba 02 purge on delete cascade, then I can do even more damage than just from drop table. You got to be real careful when you drop things, as you know. What this would do is say, all right, I'm not only going to drop imp, I'm going to drop all of its children and its grandchildren and its great-grandchildren. The drop will cascade. Okay? So there is a way around the problem, but it's brutal, because then dropping one table results in dropping a lot of other tables, and you might not even know how many tables those are. It could be all kinds of foreign key constraints floating around. All right. So anyway, that's our first look at on-delete cascade. That means that the drop command propagates to children so that you're not violating the foreign key constraints. Yes?
Do you need to use the purge keyword with that, or does it automatically get removed, or is there some traceability usually left behind?
Don't know for sure, to be honest. What I can tell you is, I've actually never done this. There's never been an occasion where I wanted to drop something in Cascade. So I haven't played, but it would be easy to set up some, very small tables and play, and then you could answer the question. Okay. Any other questions that I might or might not be able to answer? Those are the two big constraints. And just to remind you, Oracle was kind enough in that error message to tie the foreign key constraint to the word integrity, which I attempted to do in an earlier lecture by saying that what does integrity mean to the world of databases? It means that the data should be accurate. How can we make the data, how can we ensure that the data is accurate? And the answer is obviously you can't. But there are little steps that you can take, and those steps come in the form of constraints. And now we've seen two of the common constraints that you use to try to assist database integrity. All right, you can't have two employees with the same no, that's primary key. You can't have orphans, that's foreign key. Let's do some others. Okay, so alter, if we could spell it, table, yeah, sure. I don't care if I misspell at this point. Bubba 02. Now let's make it info. And this one I actually might ask you to do because it's a natural one. Add constraint. I'm not going to worry about whether or not I spell it right because I probably won't. And then it would be info Bubba 02 uni. I like this example because it's a short field to type. And then I want this to be a unique constraint, and the two-letter abbreviation that we use there is UK. Okay? So I'm adding this constraint, and the constraint is unique. And I'm going to make the uniform number unique, which is, a good thing to do. The whole purpose of the uniform number is to make money. I'll get there. The purpose of the uniform number in theory is that no two players should have the same number on their back. All right. But then you can print something called a program for people going to the game, and you can establish a one-to-one correspondence between uniform numbers and player names and statistics about the player. And then you can sell that to the customers. Yay! And that way the customers know which uniform number belongs to which player. All right, so like I said, it's to make money. You can sell programs. All right, so this is the syntax, and the usual alter table drop constraint will work. And so, okay, I think we're done with this, with one exception, and that's a baseball thing. Let's see. I'm starting to think of things to say before the first break. On Thursday, I am going to try to get names of people to bring food for a food night on Tuesday, on the next Tuesday, if you remember. So you can be thinking about that. I'm sure that you're not the unique cook wherever you live, and I'm sure that wherever you live, you do some of the cooking. So you can figure that out with your housing unit, and we'll get some volunteers to bring something next week. Now, back to baseball. There is an occasion where uniform numbers in baseball are not unique. So this is purely a baseball question, but sometimes baseball questions make it to quizzes. Fair warning. All right, what's the occasion? On what occasion in baseball, Major League Baseball?
Jackie Robinson.
You got it. Uniform numbers are not unique on one day of the year. And that's to commemorate the first game played by Jackie Robinson. And so this story goes on a bit. And Robinson isn't one of our players, okay? But he was a Californian. Jackie Robinson played football for, I think, UCLA. And he was a multi-sport guy. For all I know, he played 8 sports for UCLA, which is, he plays more sports than any other university in the world. So baseball was not integrated for decades. They started baseball in roughly 1890. And through 1846, African Americans couldn't play on a major league team. And there was a period where Hispanics couldn't either, something I didn't learn until this year. Maybe some Hispanics, but not all Hispanics. Okay. So there were leagues called Negro leagues, in which pretty much all of the players were black, but not necessarily. They were not discriminatory. Whites could play in the Negro leagues. So could Hispanics, and several Hispanics did. All right. So, I don't know. Some of you were probably around last summer when the movie 42 made its way around. And the significance of that number was that was Jackie Robinson's uniform number. Okay. When he got to the major leagues. So on the anniversary of his first game, every player on every team wears number 42. And the uniform numbers are not unique for that day. All right. Just to tie that to the class database a little bit, the guy who hired him was Branch Rickey. Well, okay, we have one more to go. Let's back this up. Yeah, I'm going to make it imp because we've talked about it so often. Let's do it. I'm going to give you an example of a simple check constraint. So the 4 kinds of constraints that we learn about are primary key, foreign key, unique, and check. All right. So check is a little different syntactically. So, but you know, we can figure out how to spell it in the usual parens. Okay? So this check constraint would say that the value of a number in the salary field has to be at least 2. The condition can be more complicated, and as with the other things that we've done, a unique should really just be a column. But this can involve multiple columns. I can say that the salary should be bigger than 2, and the position name should not start with the letter Z, and the incentives cannot have to be less than 50,000. And I could put ors and ands in here. All right. So I can make this this condition fairly complicated and get a lot of things done with a single statement. Okay. So sometimes people do that. That way they don't have quite so many check constraints floating around. All right. Any questions about these guys? I will give you an assignment in which you have to do the obvious 6, the obvious 4 primary keys and the obvious 2 foreign keys, and then fool around with unique and check a little bit. Now, here's something that I didn't make up a file to show you. But let me suggest some things that you could do. Well, we could do this online. After the first break, I'm going to go online to the simulator. Let's see, what on earth was I going to talk about? It was more fun talking about baseball. So try this on some oracle when you get in contact with some oracle. If somebody's connected, you can try it now and give me some feedback. Describe user constraints. This is like user catalog. It's a meta table that every user schema has. And so, you're gonna, whenever you have an oracle, you've got a table called user constraints. And if you do the describe, it wouldn't surprise me if you got between 10 and 20 column names. These meta tables can be pretty complicated, and no one wants to know everything there is to know about what's in the table user constraints. But it will tell you the constraints you've got on your tables, and it has little abbreviations, kind of like my, PK, FK, but one-letter abbreviations. It's probably like P and F for primary and foreign key. To give you a short description of what kind of constraint it is, and then further information about it. So, one of the things that you want to do is, especially if you're a newbie in your and you don't know what the constraints are, and this will tell you all of them for your schema, but you can restrict it by saying select constraint name, comma, constraint type from user constraints, and then you only have to look at 2 of the 18 columns or whatever it is, right? And typically, I never want to see more than 2 or 3 columns. And constraint name and constraint type, I know, are 2 of the column names in the meta table called user constraints. All right. Okay. I think that's gonna do it. I think we've reached our break. Does anybody know what year number 42 played his first game? 47 is right. Very good. All right. Collectively, a large group of people have an amazing amount of wisdom. Individually, we might all suck, but collectively, we're pretty good. All right. So let's